Hi students, today we are going to discuss few compounds of nitrogen like dinitrogen, ammonia and oxides of nitrogen from the chapter P block elements. So first we'll start with dinitrogen. As we have already studied some few properties of this nitrogen, right? So nitrogen exists as gas, nitrogen exists as diatomic molecule, nitrogen have very low catenation property and thus it exists as diatomic molecule, right? Now what is the reason for that? So we know that because of very small size and high electronegativity of nitrogen, it have unique tendency to form p-pi multiple bond, to link with itself. So for that reason in nitrogen there is a triple bond, and because of this, so this is in a gaseous state, so this is a diatomic molecule, and also it is very inert at room temperature because of very high bond dissociation enthalpy of nitrogen. Okay, now next we are going to discuss the preparation of nitrogen. Nitrogen is prepared commercially, okay, by liquefaction and fractional distillation of air. We know that air contains some oxygen, right, and it has boiling point 90 degree, which is higher than that of nitrogen. So for that reason, so liquid nitrogen will distill out first, leaving behind this liquid oxygen. Now next, so in laboratory, okay, so dinitrogen is prepared by reaction of your ammonium salt with sodium nitrite. So on doing this, we'll get nitrogen, water, NaCl. So these two remain in the solution and this will be in a gaseous state, right? During the preparation of nitrogen with this process, okay, so a small amount of nitric oxide and nitric oxide and nitric acid is formed. So this gas, okay, is allowed to pass through sulfuric acid, okay, containing potassium dichromate, where these two will get adsorbed, giving your pure nitrogen. This nitrogen is again prepared by thermal decomposition of ammonium dichromate. Okay, what it gives is nitrogen, water and chromic oxide. So again this is another preparation of nitrogen in laboratory and very pure. Okay, nitrogen can be prepared by thermal decomposition of sodium azide or barium azide. So this is barium azide. So on thermal decomposition it gives barium and nitrogen. So sodium azide also on thermal decomposition gave sodium and dinitrogen. Next we are going to discuss, okay, properties of dinitrogen. So we know, right? So dinitrogen is colorless, it is odorless, tasteless and it is non-toxic gas. 72% of atmosphere contain nitrogen, right? So now, so yeah, isotopes of nitrogen. So there are two stable isotopes of nitrogen, nitrogen 14 and nitrogen 15. And it has very low solubility in water, so about 23.2 centimeter per cube liter per liter of water at 273 Kelvin and 1 bar. Then it has very low freezing point and boiling point. So now next let us discuss chemical properties of dinitrogen. So as I've already discussed that dinitrogen, right, it is inert at room temperature. Why? Because of the triple bond between nitrogen atom and because of very high bond dissociation enthalpy. But with increase in temperature, what happen is your nitrogen, okay, at very high temperature, nitrogen directly combines with metal and some non-metal. So for example, so lithium, which is a metal, plus nitrogen, when the two combine it will give lithium nitrite, okay. Then next is your magnesium, okay, nitrogen and magnesium combines with nitrogen to give magnesium nitrite. So on heating, so when your nitrogen combine with metal, okay, this is your ionic, it gives a ionic nitrite. So and your so nitrogen again combined with non-metal also at very high temperature, like so nitrogen, when you combine this with hydrogen, okay, it gives your ammonia, Okay, so this is what called your Haber's process. So the preparation is Haber's process. So this again detail we are going to discuss in next topic. Okay, so and if you heat it, so this nitrate which you are saying, this is your non-ionic one or covalent nitrite. So whenever your non-metal, right, combine with metal, it give ionic compound, and when non-metal will give a covalent compound. So again, so nitrogen, okay, so can combine with oxygen at very high temperature to form nitric oxide. Okay, so this is the some chemical properties of nitrogen. Now let us discuss some uses of dinitrogen. Okay, so it is used, okay, for the manufacture of ammonia by Haber's process. Okay, and some industrial nitrogen compound like calcium cyanamide, CaCN2. Now, so this is also used where an inert atmosphere is required, right? And liquid nitrogen, so it is used as a refrigerant, okay, to preserve some biological materials, so food items, isn't it? And in cryosurgery, so this is a surgery, okay, which is or in which, okay, your diseased or abnormal tissues are destroyed or removed by freezing it using liquid nitrogen. Now next, now ammonia, okay, so it is present in small quantities in air and in soil, where it is formed by decay of some nitrogenous organic matter like urea. So what is the formula of urea? NH2 C double bonded O NH2. Okay, so this will decompose. First it will form ammonium carbonate, and this will decompose to give ammonia, okay, water and carbon dioxide. The next is, okay, on small scale, okay, or in laboratory, so we can prepare ammonia by treating, okay, so ammonium salt with base, like if you treat ammonium chloride with base like calcium hydroxide, then what happen is this now will break to this ammonium ion will give you ammonia, okay, then your calcium and chloride chloride will form calcium chloride and water. So again some ammonium salt like ammonium sulfate, okay, so this will react with base like sodium hydroxide, then what it will give? So ammonium ion will decompose to give ammonia, okay, and your sodium and sulfate will give salt sodium sulfate and it form water molecule. Then now commercially, so ammonia is prepared by Haber's process. So the step involved is like nitrogen, it combines with hydrogen to give ammonia, okay, and the catalyst, in presence of catalyst, so it's very important, iron, okay, which is in solid state. So for this reaction reason, so this is heterogeneous catalysis reaction, right? Then here we use is promoter, which increase the activity of catalyst like potassium oxide, okay, and aluminium oxide. And so the reaction, now this is your, okay, exothermic reaction. Now according to Le Chatelier's principle, with increase in pressure, okay, the rate of reaction or the rate of forward reaction will also increase, or the formation of ammonia becomes favorable. So here in this case the pressure or optimum pressure, okay, where the yield is maximum, so this is about your 200 into 10 to the power 5 Pascal or 200 atmosphere, okay, then temperature, so is about your 700 Kelvin. So these are the optimum temperatures. So these are the favorable condition for the production of ammonia or manufacture of ammonia. So one catalyst used is iron, promoter, potassium oxide or aluminum oxide or molybdenum oxide. Okay, and optimum pressure is like your 200 into 10 to the power 5 Pascal or 200 atmosphere, and the optimum temperature is around approximately 700 Kelvin. So now properties of ammonia. So it is colorless gas but with pungent odor, okay, smell. So its freezing point is like 198.4 Kelvin. Its boiling point is 239.7 Kelvin respectively. So and in liquid and solid state, okay, it exists in liquid, solid, gaseous state. So in liquid and solid state, okay, so there will be a formation of hydrogen bond in ammonia. So for this region, okay, the boiling point of ammonia is very high. Then the ammonia, and we know the structure of ammonia, right? So it have sp3 hybridization state with one lone pair, right? So it have 3 bond pair and 1 lone pair. The structure is your pyramidal, isn't it? Now, so because of the presence of this lone pair, so this act as a Lewis base. So this is a Lewis base. So that means it is able to donate its electron pair, okay, lone pair, and form linkage with metal ion, and that means it form complexes, right? And for the reason of its ability to donate, you know, this electron pair, so this is also a very good ligand. Ligand means which donate a pair of electron to the metal ion, and when it donate a pair of its electron to a metal ion, it form a complex compound. So this is like this we are going to study in your coordination compound, okay, and because of its property, like property of donations of electron to the metal ion and formation a coordination bond, okay, is helpful in detection of your metal ion such as copper ion and your silver ion. So like, so your copper ion, okay, so solution ammonia. So we know the color of copper, right? Copper sulfate. What is the color of copper sulfate? It is blue, right? So when you add ammonia, ammonium hydroxide aqueous, okay, then what happen is the color will become deep blue. Why? Because of the formation of the complex. So Cu NH3 4 plus 2. So here, so complex compound is every time denoted by square bracket, okay. Here 4 ammonia will donate a pair of electron to copper and form a complex, and because of formation of this complex, okay, the color will become deep blue. So I'll show you the structure of this one. Okay, the structure is either tetrahedral. So NH3. So এটা কি হচ্ছে তিমারকো? So ammonia, so this arrow means, so it is donating a pair of electron and forming a bond with copper, and this arrow represents the bond, okay, the electron which is there in the bond belong to your nitrogen only, and it is donating to copper. So this is what called coordination bond, and this is your complex compound. So again your deep blue, your blue color of your copper sulfate solution, okay, changes to deep blue when ammonium hydroxide is added to it. So similarly, so we know silver ion, right? Silver ion, if chloride ion is there, so when you treat your silver nitrate, okay, with your sodium chloride, then you will get white precipitate, okay. Why? Because of formation of silver your chloride, this will give white precipitate, okay. Now, so when you silver chloride, okay, so when you now add ammonium hydroxide to it, okay, or ammonia, aqueous ammonia, when you add ammonium hydroxide to it, then what happen is your this white precipitate will disappear, okay. White precipitate will disappear. Why? Because of again the formation of soluble complex, this one, okay. So this is how, so one can detect your presence of silver ion or your copper ion. So copper ion, yes, plus 2, sorry. So copper ion, okay, with ammonium hydroxide gives deep blue color because of formation of this complex, indicating the presence of copper ion. Suppose your silver ion is there, chloride ion is there. When the two combine, it will give white precipitate. And when you add ammonium hydroxide or ammonia, okay, the white precipitate will disappear because of formation of your soluble complex. Now lastly, the uses of ammonia. So it is used to produce various nitrogenous fertilizers like urea, okay, ammonium sulfate, ammonium phosphate, ammonium nitrate. Then so it is also used to manufacture some inorganic compound like nitric acid. Then liquid ammonia, okay, like your liquid nitrogen is also used as refrigerant.